Hi, everybody. We'll just wait for here before we start up.
Good morning, guys. Just a few minutes more. We have got people coming in from across various time zones. Just a couple of minutes more before we start. Thank you.
Okay, hi guys. Welcome to the session. Good morning, good evening. We have people from all time zones. So morning for some and good afternoon and good evening for some. Okay, so we have collected out here in order to have a power pack session on intelligent data governance framework. We have some speakers from White Clay, Helvet Packard Enterprise, and Tiger Graph. I'll just do a brief introduction on all of them before we can start off. We have Mr. Aditya Naidu. He is senior director at Yelp, an industry consultant, ex Accenture, passed out from Cambridge University. He's going to deliver the keynote for us. So here's a short bio and an intro to Adi. Adi is a customer obsessed leader with 14 years of deep B2B telecom media publishing and high-tech experience. I know Adi for a long time as of now. He's played across broad range of roles inside management and consulting and digital marketing. He has a strong track record of leading and delivering large operations at level and relevance at CXO and CXO levels. Adi is passed out from, he's done his MBA from Cambridge University. So I will pass this handle to Adi in order to begin with this particular session on data governance.
Many thanks, Amit. Hello, everyone. Welcome to the webinar. I will just share my screen and then we'll get going. Amit, could you make me the host, please?
Yeah.
Right. Let me know. I hope everyone can see my screen okay and hear me as well.
Yes, we can.
Wonderful. It's a pleasure to be talking to all of you. I thought I'll humor everyone with these two very funny Dilbert comic strips, which pretty much summarize the state of play of data in organizations these days, right? And the question is, do organizations, big and small, really know what to do with the data? Do they have the right data strategy, the right data governance, the right data monetization policies in place? Or perhaps organizations are just reacting and responding to situations as they come. Or maybe they're trying to imitate what some of the leaders are doing in this space, right? Regardless, a lot has been said about data, a lot is being done, but more needs to happen, given we are at sort of a cusp or a tipping point in this whole sort of remit with data. And why is this important? Because data is the new oil in the digital economy. It's the new currency, the new weapon for organizations, big and small, to not only thrive but succeed in the way things and the lifestyle in the world is shaping up. So before we go further, I wanted to get all of you to do some thinking. So here's a question for you. How much data does a Formula One car send back to the pit per lap? And maybe you can take 10 seconds to think about this in your mind and just answer it for yourself before I reveal the answer. I'll just give everybody 10 seconds. Okay, so well done to those who got this right. It's 2 gigabytes, but multiply this by 25 cars per race and then roughly 70 laps per race. That's a lot of data being created in one single event, right? So think about, whether you work for big or small companies, the sheer volume of data that's been generated on a week or a month, both inside and outside the organization, right? Huge volumes of data. So to do the right things in the right way with the data is very important. More so because the pressures on organizations these days is immense from all directions, right? Customer behaviors has changed, lifestyle has changed. Customers are expecting hyper-segmented products and services to suit their needs and demands. There is a lot of transparency out there. The digital world has opened up and shifted the tip of balance on information, right? People can search for many things about any company, pricing and commercial or whatever. Fraud and cybersecurity, my gosh, we cannot spend enough time on this, right? Such an important area for businesses, large and small, and no one can ignore this anymore. Marketing is becoming very tailored to capture and retain customers and make them loyal, right? Gone are the days of broad-based TV and radio advertising. It's all changing through social media. There is an onslaught of digital technologies, AI and machine learning. And pretty much every product these days, come to think of it, is a connected product, right? There is more value of a product or service in its data than in its look and feel. Not that it's less important, but even products and services, these are creating a lot of data. And then finally, there is this urgent need to be innovative, right? And do this very quickly and not wait months and years to transform or do something new within a business. And if you think about this deeply, data is the source or the mother layer to empower organizations to behave in the right way and to respond in the right way to some of these challenges, and maybe be 2 or 3 steps ahead of the game. organizations who get their data strategy right and everything below it, so governance and monetization, are actually enjoying a lot of success, and success is inevitable, right? Why? Here are some flavors for you. There are many more, but if you get this right, if you know how to use your data and do the right things with it, obviously it will help break down business silos. The business functions and their leaders will talk the same language, right? There is no ambiguity because you are using data to make the right decisions. The leadership gets empowered to make the decisions and back them up, right? And less finger in the air and more scientific approach to doing things. It removes operational inefficiencies from the business, helps make businesses leaner. And more importantly, on top of all of this is, if you are doing right things with the data in the right way, the chances of you succeeding in introducing machine learning and artificial intelligence and generally digital technologies is much better, because you're able to train all these machines and tools using historic data in the right way to make the right future decisions. Yeah. It also helps you overall, makes you very agile in the way you're looking at innovation. Innovation doesn't have to be a big 2 or 3 year transformation, right? Those are little things that you can change in the entire value chain of a business to be better, constantly be better, right? And look at the likes of Netflix, Google, Facebook, Amazon, the way they are moving and the pace at which they change and come up with new products and ideas. They couldn't do it if they do not get the data right. So what is holding all of these together? So call these the big themes or big pillars or whatever, and you would hear a lot about this in the rest of the session today. But let me just briefly introduce and summarize these key points. So data governance, one of the most important, and this is all about how do you remove data inconsistencies in different systems across any organization, big or small. How do you fix data integration issues across various systems? And more importantly, remove all the errors in the data for accurate reporting. And reporting has been talked about so much these days, right? Everybody within the organization uses them. So for you to get those reports right, data governance is sort of the overarching layer, very important. Data exchange, a sort of a new concept that's coming in now, all about gathering, organizing, transferring, and exchanging data across a firm's value chain, from product all the way to delivery and returns. This is so important to have full trust and transparency in data. Again, a very important topic with everything that's out there around fake data, cybersecurity, to have this sort of a trusted and transparent platform, exchange platform, where anybody within a company can trust the data that's there and use it to create insights and take the right decisions. Monetization, this is more than just selling data, but creating a tangible economic value from data across the value chain, again, not ignoring any one particular part, but looking at everything in totality. So think about data as a service, or creating insights from data where you can attach some tangible economic value to it. Yeah. And then finally, data culture, more like making data the way of life in an organization, and not just thinking about data when you need to create a fancy report. This needs to become part of the way you hire people, recruit people, train them, the way you perform your operations, the way you run your business as usual, the way you launch products. Data thinking and the data-driven approach needs to be part of the entire value chain. So with that, I'm going to stop, hand over back to Amit. There is a very interesting line of speakers covering all of these topics in detail, and I hope you guys enjoy the session. Thank you. Amit, back to you. I will stop sharing.
Thanks, Adi. Thanks for an insightful session. And, rode straight for this particular session to go ahead. What we will do, okay. So for the next presenter is from Whiteclay. So we have Asit Parija from Whiteclay, who's going to be presenting on democratization for data governance. Asit has been a big data, technology enthusiast for over, 4+, I would say, around 10+ years now. He's worked as architects, and he's worked at, roles wherein he's got his hands dirty across a lot of big data technologies. Asit holds a dual degree from IIT KGP and currently serves as the CTO for Whiteclay. What I'll do is I'll transfer the handle to Asit. Asit, you can take them through the journey for democratizing data.
Hey, hi, thanks, Amit. So just a minute. You make me the host.
Yeah. You have the handle now, Asad.
So let me know if you're able to see the screen.
You have to be a little louder, Asad. I think the voice is a little low.
Hello, better?
Yeah.
Hello. Yeah. Hey, hi everyone. Good evening, good afternoon. So, hi, this is Asit. I head Whiteley Technologies, and what we'll do today is we'll go through the value chain of data and how democratizing data and how data governance plays a very important aspect when it comes to doing anything related to data inside any organization. So let's go through a kind of a data journey. So if we see the whole idea of data, we came long back, like somewhere in 1960s, when information technology or mainframe computing just started to play its role. Now, during that time, typically data was a kind of a process result. When I say a result, there were mainframe computers you used to crunch or do certain kind of activity, and the byproduct of it was a kind of a data. So data was treated more like a result which came out of doing some kind of a computation, and the byproduct was data. Going forward, when during the 80s and the 90s, the the systems came into play on the ERP side, on the MRP side, which kind of started using and collecting data, and their data became more like a process enabler. When we say process enabler, like for example, when people wanted to do accounting, they wanted in the systems to store data, and the whole idea of data was to enable a particular kind of a process, like an accounting or doing an order to cash, procure to pay, something, some use cases like that. Moving forward in the last decade, when electronic business came into play, the Web 2.0 revolution started happening. Data became more like a product enabler. When we say product enabler, the data was utilized to do various kinds of innovation. Data was utilized for doing products, service system, to build integrated solutions so that the data can become a more like an enabler for doing various kinds of businesses. And starting today, like on the last, not even today, like for the last decade or data has become more and more like a product. And when we say like a product, data can be treated. We always tell that like data is the new oil. Now, when we say oil, oil is a product. Similarly, data has become a product now. And when we are treating data as a product, it becomes equally valuable or equally important for us to uh, store the data in a proper way, for us to use data in something like we use money in our balance sheets, or we used various kinds of other assets in our balance sheet.
Asid, sorry for the interruption. We have got some people waiting. You are the host. If you can just let them in. We have got some guys who have just joined.
So just give me a minute. Mhm.
Yeah, those three dots over there down.
Sure. Everyone has been unmuted. Okay. So when we're treating data, so even Adi touched upon that, like data is the new oil. Like, and if we see how oil behaved, like oil, the value of oil came majorly because it was getting used a lot, and it was getting used at different places. Now, if say imagine like if the oil was tapped inside the earth and nobody used, or nobody created products which used oil, the value of oil wouldn't have been there. Similarly, when we are talking about data, data also, like oil, needs to be extracted, refined, and pumped. And this whole system should happen seamlessly so that the value of data keeps on growing and growing. Now, there's an interesting set of graphs which I'll be showing you. And what it shows is like how the value of data can be put across various kinds of different parameters. And we can see what is the tangible value of data. Now, if we see the certain of the graphs out here, now if we see the share of value versus the number of users, what it says is like if we have X number of users using the same data, does the value grow? And yes, now the value, if 10 20 people are using that kind of a data, the value of the data comes from the data itself. So everyone will have its 100% value. Now, the more the data is getting used, if we look at the second graph, the more the data is used, if you see that the value of that particular data asset keeps on growing and increasing, keep on increasing. So the more the data is exchanged, the more the data is used, the value of that data keeps on increasing. Similarly, in the third graph, if we see, if the data is say sitting idle, and say if we are storing data, like in most enterprise systems, say earlier in the earlier generation, data was getting created, but it never used to get shared, and it was just sitting in time in a particular place. Or you can imagine data getting stored in tapes. Now, in those cases, what happens is with the value, as and when the time goes uh, by, the value of that particular data keeps on growing down. Now the potential, with the time, if we do not exchange the data, the value of that particular data set keeps on going down. Similarly, if we see, the more quality of data increases with time, the value of the data goes high. The better the quality of data, the more is the value of that data. Similarly, if the data is very well integrated, the data is very well shared across various players in the ecosystem, the value keeps on growing. And similarly, the more amount of data or the more volume of data we have, the more the value is. Now, if you see this particular graph out here, with the increase in volume, there's an increase. And if you feel like at the end, there's a slight dip. Now, one of the reasons, like most of the organizations who are generating lots and lots of data, after a particular time, they don't see value going up in an increasing trend. This is majorly because uh, tools which were developed earlier, or it becomes really, really expensive to get value of the data when the volume of your data is high. Coming over to data democratization. Now, when we what we saw is like data is can be treated more like a product, and data, the value of data comes only when it is effectively exchanged, as well as refined, as well as moved across various departments or various organizations in real time. Now, what do we mean by democratization? The idea of democratization is the ability to allow specialists as well as non-specialists to easily exchange information so that they can analyze the data, is called democratization. So as the word democratize, which is comes from the word democracy. Now, if we see, in a democracy, everyone knows how to, or everyone has its own contribution in creating in the value system. Similarly, the whole idea of democratization or data democratization is that the data, it can be easily shared across various members within the organization, and also some people outside the organization. It can really, really come with great value and give great value to the industries. Now, if you see, like currently, I think we are moving towards something called as an industrial 4.0. The idea of industrial 4.0 is like completely on based on data sharing and data exchange. Now, the with the whole advent of IIoT and smart tech, smart cities, smart factories, the idea is that if the smart factories and the smart cities, they start sharing data seamlessly across each other and start collaborating with each other, the whole value of data will keep on growing high, and there would be more connected systems in a coming generation. Now, data exchange can happen both across within the organization. If we see on the horizontal access. There could be within a particular organization, data can be shared across, and also data is now getting shared across different domains. So for example, let's take an example of something like a smart city. Now in a smart city, if we see, it's basically the data is getting shared, or the data generated from various systems is not in a siloed way. Though the data is getting generated in a siloed way, the data is very smartly moved across various components to generate value and to solve very good use cases which can be very beneficial to the country or the city by itself. Now to do all this, what you need is a kind of a set of goals, as well as a set of tools which can help you to easily share, as well as standardize the way you share data across various kinds of people, various kinds of tools, etc. Now, coming to the need of democratization, so what is the whole idea of democratization? So, as we need, as we have already looked upon, data being an asset has to be shared across to create more and more value. Now, what leads to a tool, or need to have some kind of software which can help us to do some kind of a software which can help us doing data democratization? Now, one of these features, some of the features of this tool should be, it should have easy and real-time access to data sets. It should be imperative to distribute information to various teams and also in real time. And also, most important, it should empower each and every member, be it a technology guy, be it being a non-tech guy. Everybody should have an access to the data. So whatever value they can add, or whatever things whatever data assets they have more knowledge on, they can utilize it, and they can add their own suggestions on it, and kind of collaborate in a world where every individual can add value to the organization by using the data, creating the data, or exchanging the data. Now, also, all of this is we would understand that, yeah, everyone understands the whole idea that data is important. Now data also can be shared across. Now what are the challenges when we are talking about sharing the data? Now when we are sharing data, some of the challenges which keep on popping up for every organization, or every even governments, when they are exchanging in large amounts of data, is based on these factors. So one of the important factors being data governance, another important factor being quality, and another important factor being data security. Now, all these challenges have been there, because when you are moving data, and when you are treating data as an asset, we have to govern it in a particular way, so that the value of the asset is not lost over time. And also, since it's an asset, it should be very well protected. So all kind of security features, as well as it should be in place, so that there's no negative value of the data which is getting shared. Now, data governance is the most important aspect of the whole data democratization story. Now, for data governance, what do we mean by data governance? So data governance is basically, like any governance, is setting up a certain kind of rules and regulations of how data should be used within the organization, how data should be interchanged or exchanged with various members within the organization, and also to even kind of provide something like an audit feature, where you would know exactly what is happening with your data, because it's an asset. So we should know exactly what is happening and who is acting on that particular data asset. So some of the important features or requirements from a data governance perspective is that business processes and sensitivity of the data it uses, it should have a very strong and lineage to it. When we talk about lineage, basically it should be very transparent how the data got generated, how it got used by a particular set of members within the organization, how it flew to move to another part of or department, or how a particular individual interacted with that particular data asset. So a very strong lineage is a part of data governance. It should have a very robust auditing features. As I said, we should know exactly what has happened to the data set, who within the organization have touched upon that data set. so that we can have a full overall governance framework which can help us to manage the data assets. Now, whenever we talk about data sharing, there's always a thing comes from security perspective. Now, we would hear from the last couple of years or even more that there's a lot of problems which are cropping up when it comes to data sharing uh, across individuals, across organizations, etc. Now, even very big corporations like Facebook, Google, they have come up into the ambit of data protection laws, what data should be shared across, because data should not be shared across, etc. Now, there's a very fine balance, because when we are talking about data democratization, if we keep everything locked up, then the value of data won't go up. And if we start sharing everything and we keep it a little unregulated, then there could be data protection issues, or we can go into legal hassles when we are sharing data and we do not have a complete view of how the data is getting shared. So there's a very fine balance between sharing as well as protection. And for organizations to be in this whole world of data democratization, they have to understand that they have to work in a very fine balance, so that informations which can be shared, personal identifier informations are not getting shared across various members, they are well protected. So they have to maintain a very fine balance. So that's some of the important aspects every organization should look into. Now let's go into the fundamentals or architecture of a data democratization tool, or if we want to implement something like a data democratization where people are easily able to exchange information within the organization with their third party vendors, maybe some information which is a non-PII information, sharing it outside the organization, etc. So what should be the architecture, or what should be the business flow in order to build such kind of a culture within their organization, or build such kind of an ecosystem within the organization? So I call it as 5 pillars of data democratization. One is being the business, the functional aspects to it, the process aspects to it, the information and the system. Now, touching first upon the business aspect to it. Now, when we are talking about business, we are talking about the business roles, or the roles which should be defined within an organization in order to have a pure data democratization or a data governance kind of a policy. Now, what we can do is, within an organization, we can classify certain peoples as providers of data, certain people who are creators of data, certain people who are consumers of our data sets. And also there would be certain electronic applications which are basically acting as both a producer of data or a consumer of data. Now, what do we mean by providers? Now,
Yeah, Asid,
providers,
sorry for the interruption, Asid. I think there are some more guys in the lobby. I'm so sorry.
sure, let me just quickly admit them. I think all are in.
Yeah, yeah.
Okay. So yeah, so talking about the various business roles, so within an organization, we can classify. So first thing what we need to do is we should identify which people belong to which kind of a particular role. Now, data providers can be classified as people who are maybe acting as CDOs, or they can be acting as particular department heads who basically are managing a particular data asset. So, for example, if I belong to an HR department, then all data which is related to maybe HR can be a part. So, I can, and if I am the head of that department, so I can become a data provider, or there should be certain members who have to be allocated within a particular department who can say that they are basically the providers of the data of their particular department, organization, etc. So there would be we have to identify that there would be a set of members who would be the providing data asset. Now there would be certain members, or uh, generally in till now these we have a set of team members who belong to the IT or the data warehousing team, or the analyst team. So they can be classified as someone like a data creator. A data creator is basically someone within the organization who knows how to play with data, who knows how to do various kinds of transformations of the data, mix and match data from various places, and create a third kind of a data set. So those can be classified as data creators. Then we have consumers of data. Now, consumers of data can be anyone within the organization, starting from the CEO to the CIO to the business analyst to the various business verticals who are basically consuming the data and trying to interpret in a way that it can be beneficial to their set of roles and activities, and they can use data readily, so that and do not have to depend a lot on IT, or even go back and go to the maybe the providers of the data to get certain kind of analysis. And the fourth aspect, the apps, the applications, if I say, they are basically the software components which are continuously generating data, so they can be acting more as providers, and as well as they can behave something like a consumer, or it could be a third party app which are basically consuming certain data sets and creating value in the complete ecosystem of data. This particular diagram shows how organizations can have an exchange of a flow. So if we are talking about a data ecosystem, now a data ecosystem consists of various players. So as we had discussed, there could be various roles like a data provider, then there could be a data creator, then there are data consumers, as well as there are data users. Now, for them to interact seamlessly, we can imagine it's something like I would say a kind of a stock market where data is getting exchanged, or there's a flow of information between various members or various roles within the organization. Now, uh, here there would in the diagram, if you see on the left hand side, we have a set of providers who are basic, and the creators of data who are basically defining how the data should look like. They are defining how the data should be, what is the vocabulary of the data, what is the metadata, how does the whole metadata look like. Metadata is basically the data about the information about data itself, like say the type of columns which we have, the type of data type we have, what is my data structure looks like. So the data provider can provide all that kind of a metadata information uh, into a centralized repository. And on the right hand side, we have a set of consumers who are basically consuming the data for various kinds of use cases. Now, in the center, what we have is a kind of a governed set of tools or set of people who will be basically enabling this kind of an exchange and enabling this kind of a flow of data, so that the whole flow or the exchange of information becomes seamless, as well as it is in a much more governed approach. So we can have something like a clearing house within our organization. We can have someone like a store where any kind of data which is getting published, it is basically going by a set of rules, it is going through certain checks and balances, and then it is available for consumption. So more like a governed approach of how data flows from creation of data to consumption of data set. Coming to the functional aspects of the whole data governance use cases, the functional architecture consists of various kinds of sets, whether tools or various kinds of functional requirements which come into play. So one of the most important factor is trust. So when we are using data within our organization, there should be certain trust associated to it. So for example, if you know that for now, if we are talking about say if we are looking at a news channel, though it's not very prominent these days, if we trust the news channel with that whatever the information we are getting is 100% true. Similarly, within the organization, it's very important to stamp the data to say that this particular data set is very trustworthy, and it can be trustworthy if we have very strong identity management. One is that if it is coming from a particular individual, or it is coming from a particular department, it is coming with a particular certification. We know that this particular data set is really can be trusted upon. The second aspect is more from a security and the data sovereignty perspective. So once the trust is established, there is also a requirement when it comes to that nobody should be able to breach that particular trust. So there should be strong authentication as well as authorization policies associated within the ecosystem. There should be proper certification, and security should be very well bounded in whatever aspects when we are talking about data. Then there is an ecosystem of data. Ecosystem of data, basically there's a lot of data sets within the organization. What we'll find that they don't have a very enough description, or they don't have all the vocabularies associated to it for it to be shared across and to be used across used across to create value. So it's very important to add vocabularies or add metadata information to our data sets, so that we understand what that the data is talking about, and we understand the data should be self-sufficient to be consumed and to be used across. From an interoperability perspective, again, like we should have a very standard way of exchanging information. Typically, till now, a lot of organizations, they face a lot of problems when they do not have, because they don't have a very standard way of exchanging information. So, for example, certain department will share information using an Excel sheet. Some people will say that my data is present in a database, so you can do a query and get it and analyze it. So there's no standard way of exchanging information. So it's very important for organization to define certain rules and standards, that this is the only way data should be exchanged, so that it gives more interoperability between various members within the organization and also between various applications. And then comes the value added apps as well as the data marketplace. Data marketplace is now coming in as a big way within organizations, where people want to are creating marketplace within their organizations, where a lot of data sets can be published and can be exchanged seamlessly. We also have now a lot of public marketplaces of data, where you can get certain public data and create certain kind of innovative stuff out of it. So with the current, so we would have seen that with COVID-19 right now, we would have seen that a lot of data sharing has started happening. A lot of countries have started exposing data of how many hospital beds do they have, what are the total patients in a particular geography, etc. And they are getting published using a marketplace where data can be exchanged, it can be bought, or it can even be used for various other activities, and which kind of drives innovation.
Asit, can you just allow certain participants out there?
Yeah. Just a minute.
So there is a question, Asit, from Munjal. In the data exchange flow diagram that you showed, what would be the difference between the consumer and the data user?
A data consumer is a data user is basically a type of a consumer, I would say. So we can have someone like a data analyst can be a data user who's using the data, and a data consumer is a kind of a broad kind of a subset of all data users. So for example, if I am creating if I am an app builder, so I'll still be getting classified under data consumers, because I need certain kind of an information which I can use to build my application, and use that data to do something out of it. Whereas a data user will be more like, who will be like mostly using the data, and maybe using it for certain. So mostly like we can see something like a CEO or a CIO who would be basically looking at the data to give certain interpretation, but may not be very tightly bounded as a data consumer who is continuously consuming the data. Is basically someone who will be uh, will be one of a user of the data set. Coming over to the information side, so we covered on the business aspects. Coming over to the information side, now the information is basically the metadata information for various things happening or various flows which are happening or data flows which are happening across the ecosystem. So when we are talking about data, so the metadata becomes the information about the data itself. Now the metadata can be very rich. It can have it can so basically we can define what this data set looks like, what is the kind of category it belongs to, what kind of protocols it is using, uh, what kind of monetization can be done from the data asset itself, who are the participants who are interacting with the data, etc, etc. So information is all about getting, so when we are talking about data by itself needs to be changed into information, and data can be transformed into information if we know or if we have the knowledge about what data is all about. So for example, if I give you a bunch of numbers, it may not give any value to it. It just maybe looks like it would be a dumb asset. But if we define what are the columns or what are the different attributes of that data, the value or the data then transforms into information. So similarly, in the whole data ecosystem, when we are exchanging various kinds of data sets, it's very important that we have a strong framework where we'll be able to provide information, or we will be able to provide enough data points or enough metadata information so that data becomes much more usable and we do not end up with a lot of dumb data sets. Coming to the third part of a more like a system. So a system is basically coming on to the technology side. So when we are talking about technology, we would be talking not from a data provider perspective, we were talking more from a role perspective out here there. Now from a technology perspective, we will be having data sources, which are basically can be various data sources. Now these days, every organization have multiple data sources. You'll be having an ERP system, you'll be having a social media feed, something like a Twitter, you would be having IoT sensors. So there would be various kinds of data sources available. Uh, and the whole idea is that from a data provider perspective, they would be able to use certain kind of connectors to connect to these data sources, publish the metadata information, publish the various kinds of information about the data. And on the left hand side, again, we have data consumers who will be again using a certain set of connectors to interact with the data, with utilize the data in certain aspects. And then we also have a data sink. Data sinks would be basically where you want to push information to, or you can imagine like something like your personal wallet, where whatever data you are more interested in from the ecosystem, you can store it in your own place where you like, so that it can be used to the fullest extent. When it comes to technology patterns, so some of you would have already heard these terms. When we are talking about the creating a full data governance as a ecosystem, as well as a full data governance framework, some of the architecture patterns come from data extraction, knowledge extraction. So words like data lake come into play. Basically, a big repository where we can store all our data assets in. Then when it comes to secure data exchange or data sovereignty, when we want to do data cleaning activities, when we want to do various kinds of transformations, etc. So it comes in the whole world of an ETL, which is basically extract, transform, load. And third, when it comes to data consistency or stamping the data or data transparency, or if you want to add, say, a particular uh, say science to our data asset. So something like blockchain technology, where every data set which has been touched upon has a mark associated to it. Uh, are some of the components from a technology perspective, which are majorly used whenever we are talking about delivering an end-to-end uh, data governance framework within our organization. Now, what we did is like as a part of our company, we studied all these kind of architectures. We studied the whole idea of data governance, of how data needs to be exchanged seamlessly, as well as it should be exchanged in a very governed manner. This gave rise to all these ideas which we discussed upon, gave rise to our inbuilt product called ISAC, which is a real-time data exchange platform. Basically, it's a platform which helps organization to create an internal governance tool, or it provides an organization a set of tools which can help them be completely reliable in exchanging information within various members, as well as providing an easy way of exchanging information between various members within the organization. The Isaac tool, it's basically comes with the same ideas of data producers, data creators, as well as consumers. What it gives is it provides you a set of features where you can publish metadata information, you can do data profiling, you can do data discovery, you can enrich various data assets, you can share these data assets with various people within the organization, as well as external vendors or applications if required, and also do some advanced analytics, something like a customer 360 product recommendation, do forecasting, or create a knowledge management framework within your organization. uh, some of the roles for which are a part of our tool, what we do is we have created various roles within the tool itself, where we have data providers who are providing various kinds of data sets. So we have a user role management within our framework, where you will be able to define within your organization are the providers of your data and what kind of access rules they should have. Then we have data creators who can take in the data, transform it in a particular way, uh, do various kinds of cleaning of the data set and publish it back into the ecosystem. And then we have data consumers, where they can consume data in various formats. They can push it into any database of your choice. They can use APIs to consume the data, as well as design certain kind of trigger rule or custom dashboards to analyze those data sets. The technology in which Isaac has been built is on a completely container-based framework. So what we do is we use Docker containers, and we are completely built on a microservices kind of an architecture, which can be deployed on a Kubernetes kind of a platform, which can be easily deployed in any cloud environment, or it can be deployed on an on-premise environment or on a VM kind of a setup. So the architecture is built in a way, in a modern requirement way, where it has been already dealt that whenever you want to move your applications from one set of hardware to another, it can be done with seamless manner. And also it provides you a kind of a very scalable framework, where we'll be able to scale very dynamically based on your requirements of your growing needs of data requirements. Some of the USPs of the products, what we do is we have provided a set of features which can help you access any data. You can do on the fly data processing. It's built on a completely distributed architecture, so completely horizontally scalable. You can build data marts on the fly, so you don't have to like create data marts and store it in particular silos. Whenever you need, you can create data marts out of the box using this particular tool. It provides a way on a self-service analytics, wherever whenever you have consumers within your organization who had to always depend on IT teams to get certain kind of information. So the whole USP of the product is that the set of tools will be so easy to use, a kind of a drag and drop kind of a feature, that any business analyst or anyone within the organization who maybe may not be very technologically advanced can also start utilizing data, because that's the whole idea of data democratization. And also for the advanced users, we provide a set of capabilities who can perform advanced analytics, something like recommendation, doing fraud detection, etc. These are some of the snapshots of our tool. So basically, we have a set of way to create connectors where we provide some out-of-the-box connectors. It's based on an open source framework. So there are multiple 100+ open source connectors which can be utilized, which can be used by the data providers to publish data assets within the ecosystem into a kind of a marketplace. Then we have something like event, which is basically a data asset, uh, which can be classified as a data asset and can be stored inside the tool. You can provide various kinds of metadata information. You can give descriptions of what that data looks like, give it a fancy image, and provide all the descriptions so that the data can be utilized by other members within the organization. We have a way of a very simple, we provide a set of tools for the creators or for the data creators, where they can easily use a drag and drop feature to interact with the data, where they want to join various different data sets, or they want to do certain filtration of their data, they want to mask certain amount of data, etc. We provide a set of tools which are focused towards the ETL developers, or maybe even the business analysts, so that they can easily pull data assets and do various kinds of transformations and publish it back into the ecosystem. And then we have a marketplace where all the data assets can be published across, and these data assets can then be utilized. So just imagine it like an e-commerce platform where you will be having various kinds of data sets. You can go subscribe to any data set. You can use that data set. You can consume it via an API, or you can use that data sets to create new data sets from them. So you can say you can take certain data sets from the marketplace, do various kinds of transformations out of it, and publish another enriched data set out of it. We also provide various kinds of statistics and profiling kind of tool sets which help you analyze or to understand how the data looks like, and even monitor how the data is getting shared across various members within your organization. Now, with the whole data democratization as well as from the data governance aspect, how it helps from being something like an AI ready, or because as we know that that more and more all organizations have to become more to move towards something becoming towards artificial intelligence as well as use machine learning kind of aspects. Now, for that, it's very important for the organizations to have both set of roles, starting with data engineering as well as data science, and a kind of a way so that both of them can interact in a very seamless manner to achieve the right goals when it comes to delivering AI based use cases. So Isaac, which is the tool provided by us and which has been created over by learning from all whatever data uh, governance is required within the organization, whatever data, whatever tools are required as a part of data democratization. We have all inbuilt together, packaged it across as an open source based tool which help you standardize data, enables innovation, drives data governance, and also help you exchange information in real time from one place to another. So with this, thank you very much, and I'll be happy to take certain questions. What I'll do is I'll go through the questions which are part of the which are being posted, and I'll be happy to answer this after the session.
So we can post questions on the chat window. We'll do a breakout after the next session. So if there are any more questions, we can take those also. But it would be good if you can post your questions in the chat window so we can have it answered. Thanks for the session, Asit. That was an insightful session. I think the goal of data democratization is, ideally to allow non-specialists to be able to gather and analyze data without requiring outside help. In an organization, we have already always seen that, we being on the business side of the, organization are dependent on the IT in order to use or make use of data in the ways and means that we want. And data democratization has actually opened up that particular format. It's like the ability of information flow across channels. But there's a thin line when it goes towards the data governance side. So when you are talking about data governance, it is more that we need to see as to whom we are allowing and how we are allowing. So with that is okay. Let me just take the. Okay, so our next session is from TigerGraph, and we have Mr. Martin Darling from TigerGraph. I think the heading of the session is a little different. Sorry for that. It's around fraud analytics. Martin is, a seasoned industry veteran with over 30 years of experience, highly experienced inside the, the IT domain. Martin serves as the GM for the Europe region, Europe, Middle East, and Africa region for TigerGraph. And he has served in many senior roles at Mappa, QLogic, Hitachi Data Systems, and EMC. So with further ado, I will hand over the handle to Martin.
Thank you, Amit. Thanks, Asit. Thanks, Eddie. Let me try and share my screen now, which seems to be the main conversation of 2020, doesn't it? Can you see my screen? So that's my question. Can you see the screen? Does that make sense, or have I got the wrong screen?
We can see the screen, Martin.
Is it all one slide, or can you see two slides?
We can see two slides. I think
Yeah.
the presenter view.
Yeah, that's what I don't want to do. I've got to try and work out how I switch monitors now.
I think if you press the down button on this slideshow, it would pop up only one.
It should. Let me see. Is that better?
Yep.
All right. Thank you, Amit. Thanks, Asit, and thanks, Eddie. So we're going to link the subject of graph analytics and fraud detection into data governance. So what I'm going to cover in the next half an hour is, I don't know how new graph analytics is to some people, so we're going to spend a bit of time talking about what graph analytics is and what's driving this market, and then we'll spend some time talking about how that fits into data governance. And then we'll spend a bit of time on a specific data governance use case, which is fraud, which seems at the moment to have the sort of highest return on investment for customers. So see if I can get to the next slide. So when we talk about graph analytics, this is quite a large trend that's sweeping across the industry. And in addition to these words from Gartner, what they've actually said is that graph analytics is the most effective competitive differentiator for organizations that are pursuing data-driven operations and decisions. So that's quite a statement. But just to explain what it is, because obviously graph databases have been around for a while, and graph analytics, which is what TigerGraph is involved in, is sort of the next evolution of the graph database world. And really what we're doing, I mean, graph is not a great way of describing what it is, but what we're looking at is a database and analytic techniques that allows us to look at relationships between entities of interest, such as organizations, people, and transactions. So what we're really saying is that in something like TigerGraph, the relationships between the data are a first-class citizen of that database structure. This it's not a new technology. In fact, I was happy that Adi talked about how companies like Amazon and Google and Netflix are constantly changing and evolving and driving the market forward. And a lot of their systems, including sort of Google PageRank and what recommendations you get for your next movie, that's all driven by their internal graph systems. So effectively what Tygraph is doing in conjunction with Whiteclay is bringing that capability to the broader enterprise market. And because of, a lot of customers have been driven online over the last 12 months, for reasons that don't need explaining, there's a huge adoption of ensuring that customers get a better service and a better experience through their online, or whether they're in a physical store, or whether they're just talking to a chatbot. That type of end-to-end analysis of customer experience, as an example, is clearly best done through Graph. So Graph is a big trend. It's growing at about 100%, compounding. And so what we're focusing on here is networks of data. So we don't replace relational or NoSQL databases. I'm going to keep letting people in. We're really focused on looking at relationships between data, and that can absolutely form part of a data governance strategy. Graph Analytics is also now covered by people like Forrester, so it's a trend that's picking up a lot of analytical coverage. So what you see here is this the later Forrester Wave report. Obviously, I wouldn't put this up unless Tygraph was in the leaders quadrant. But I think one of the more important points is that both Forrester and Gartner are predicting that, as it is today, about 15% of enterprises worldwide are using Graph technology. But they predict that 85% of enterprise organizations will be using Graph within about the next 24 months. And this is a way that it's driven by clear competitive advantage that companies get. As we mentioned, organizations like Google and Netflix have been using Graph technology to drive their businesses forward for a number of years. And now we're beginning to see that more broad adoption in the enterprise marketplace. So I'll cover a little bit on what we're actually talking about within what makes up a Graph Analytics platform. So it starts with a distributed graph database. So Tygraph was built from the ground up to be distributed, whether on-prem servers or in cloud, but to deal with today's large data sets. And the original sort of graph databases were quite small in size, whereas Tygraph can scale up to multiple terabytes across multiple servers, whether it be on cloud or on-prem. And ultimately, it's a database that scales with the customers. And the idea is that it's very easy to connect all of your data sets and pipelines. So a real clue as to whether you have a use case that's well fitted to a graph database, a really simple way of looking at it is, do you have a lot of joins to make in your database, or do you have a problem with the number of joins? So if you look at some of our customers like United Healthcare Group, who are connecting over 200 data sets and pipelines. One of the largest online retailers is over 100 data sets. And Xandr, which is the media streaming entity of AT&T, is connecting 50 different pipelines together and then running analysis across those pipelines. And the point here is it's very quick and easy to add new data sets and new pipelines into a graph database. You don't have the problem with joins because we don't have to do the whole table update. You just literally add the data set that you need to add into it. And only that one join takes place. So it's being driven by people who want to connect lots of data sets and pipelines together. The next thing is that the computer language runs advanced analytics within the database so that we can run complex analytics whilst the data is in situ in the database. So a good example there is Jaguar Land Rover. I'm sitting here in the freezing cold in the UK. An example of them being able to answer analytical queries that they couldn't answer before, where we have this bold claim of 3 weeks to 45 minutes. The specific example here is they had a couple of thousand Range Rovers sitting on a factory production line in Slovakia. They're about to fit 1,500 tow bars, and then they found out that the tow bars were faulty. I'm not telling trade secrets here. They publicly stated this in a use case document, so it's okay to talk about problems with suppliers. So the question they then have to ask, it's £2 million an hour for downtime. So the question they have to ask then is, so which cars in their sales order bank should they now build? So the question is, what cars look most like the ones we were about to build, but don't have a tow bar? And that's not as simple as you might think, because different models like Range Rovers use the same physical chassis as a Range Rover. Now, they were able to write that query and run it in about 45 minutes, whereas actually previously it would have taken them 3 weeks to manually go through the sales order bank, because you need a lot of data in that graph. You need all of the parts. I think there's about 4.5 billion in total, including all the iterations of parts. And you need access to the whole sales order bank. And you also need to know which parts are in that particular factory. So it is quite complex. And that's kind of the point we're making here, is these people are answering questions that they were unable to answer previously. That's not something that you could do that quickly in a relational or a NoSQL database. And then the last thing is we plug directly into machine learning and AI. So a lot of the time when we're involved in complex fraud detection, which is the customer example here is Intuit, they're using the graph database to generate in real time new features and training for the machine learning engine. Ultimately, this is about providing context, additional context around the data. So using graph, they're able to understand the relationships between the data, particularly when it comes down to fraud. They're able to understand the relationships between people and location, and maybe phones or computers that are known to have been used for fraud previously. And they can add that, they can use that context from the graph database and feed it into their machine learning engines for recommendations or fraud detection. And they can do that in the database itself without having to run a separate process. So this plays really heavily into the whole machine learning and artificial intelligence journey that we're all on. So the way this fits into data governance is, and we do get involved a lot in data management, data lineage, because of the challenge of the last 20 years. There's a lack of visibility, and particularly what Graph is good at is working on the predictability. You can create a lot of what if scenarios. If this fails or if this is wrong, what else will be impacted? That's what we would call a classic graph shape problem, because you can test and model what the impact of a change would be using graph. So people have been looking for more flexibility, to be more adaptable, more timeliness and more control. And then, the bottom point to the last 20 years is that things haven't been joined up in terms of governance, operations, and business. And what we're able to do with Graph is very simply join them up in a very simple way so that we can have that single overall view. Because now the future is joined up, it is dynamic, it's got to be fully trusted and compliant. So we're moving from this foundational to transformational, where the data-driven alignment, we want to be able to track everything, moving parts in real time. And we want full visibility and predictability to change. And one of the really big drivers for Graph is to do real-time risk aggregation. And that sort of plays into what I'm going to talk about in a little bit about fraud. And this is why Graph Analytics looks different to what people are used to seeing. People call this the sticks and balls diagram. But what you're really able to see here is the relationship between the different data sets that you have. And this is a view that's really only available within a sort of graph analytics platform. The database performs very much as any other database works. In fact, one of the quotes from sort of Jaguar Land Rover head of analytics is that, why torture your data and your data model to make it fit into rows and columns? When you draw up a data problem on a whiteboard, it kind of looks like this diagram in front of us here. So why not just map the real world directly and natively into your Graph Analytics database? it saves a lot of time and it makes it a lot easier to understand the flows and the processes of the data. So that's what it sort of looks like from a graph database point of view. But obviously, when we roll it out into the business, people want more of a professional view. So there are many different ways that we can visualize the data so that it can be driven directly by non-technical people. So we have ways to provide screens, user interfaces, so that the operators don't have to be, SQL experts. For example, with one of our largest customers, which is United Healthcare Group, they have about 30,000 people working in call centers, working on their customers. And obviously, they're not all using sort of SQL or very technical screens. So there's a lot of options on how this data can be viewed by the business. And that's why we work with partners like Whiteclay, because each of these needs to be optimized and customized for that customer's specific use case. So I want to talk about one specific use case, which it's driving our business today simply because it has an immediate return on investment. We all know we're living in difficult economic times. So if you can show an immediate bottom line impact, then that's something that's good for the business and it's good for companies like Tigergraph and Whiteclay. But while I am going to talk about fraud in the context of financial services, I would just step back for a moment and say we are solving fraud problems in many industries, from telecommunications, where it might be something as simple as revenue leakage. We have use cases to do with handset theft. We have use cases to do with even premium numbers being stolen and resold on the grey market and not paid for. But for the sake of this presentation, sort of 10 minutes I have left, what I'll do is just walk you through how Graph is used within the financial services industry. Predominantly here, we're talking about credit card fraud, but this can, as I said, this can relate to anybody who is, conducting a fair chunk of their business through the credit card. So we have retail customers who are selling electronic equipment online, and they are liable to a certain extent for fraudulent payments. So we're seeing a lot of large retailers and payment gateways adopting similar systems to the traditional banks and credit card companies. And the same is now happening in areas like Africa, where we're seeing telephone companies, offering mobile payment systems, and then they are just as exposed to fraud as a bank is. So we're seeing these types of use cases deployed in telecommunications companies as well. So the point there is that fraud is not something that's just limited to financial services. And sadly, during these difficult times, fraud is increasing as the economy gets more stressed. There is an increase in fraud, and if you can stop that fraud, then it has an immediate impact on the bottom line. So fraud's a big problem, about 30 billion worldwide. But it's interesting, if you get into the fraud argument, it's actually the bigger loss comes from the full customer lifetime value. So actually, whilst the fraud payments are large, there's actually more business impact, or I should say negative business impact, from legitimate transactions being declined. Because obviously one way to eliminate fraud is to not approve any transactions. You will have achieved the goal of having zero fraud, but you will have very unhappy customers. So, it's about 1 in 5 block transactions are actually fraudulent. So what you'll see we're very focused on in our use cases is we're looking to reduce the number of fraudulent claims, but we're also looking to eliminate what we call false positives so that we accept as many good transactions as is possible, because that's where the longer term damage happens to our customers' business. So this is the way that Gartner looks at the framework of the total cost of fraud. I mean, there are the losses from fraud when somebody steals something from you using an illicit card or some kind of chargeback. Then there's the tools and headcount costs. If you don't have a highly automated system, then you have to have a large number of manual human resources to do the fraud investigation. And that's both slow and cumbersome. And then the third element is this customer lifetime value. You're looking to understand what is the impact of somebody who has had a legitimate transaction declined. Because these are the types of customers, you know, if you've had your credit card declined twice in a day, you probably won't use it again. You'll probably go to another card, and that is then a lifetime of lost business. So this is a huge issue, and it's a huge opportunity for improvement, both to reduce our customers' fraud losses, but also to improve the customer experience when using a financial vehicle. So again, this is a Gartner slide, which really indicates quite a simple message that what we're looking for is to find that sweet spot where we have reduced the number of frauds, but we've also reduced the number of false positives. So we have the smallest number of frauds happening, and we have the most happy customers having legitimate transactions approved. And sometimes that takes some education of the internal stakeholders who just want to focus on decreasing fraud at all costs. And sometimes it needs to be explained that this will have a negative impact if you start to impact legitimate transactions. So this is a bit of a busy slide, and I hope I'm able to explain it. But what we're doing with graph analytics is we're bringing more context, we're bringing more data into the existing fraud systems. We understand that fraud detection is not new. Every organization that is dealing with electronic transactions has some type of fraud detection system in place. But what we're seeing, and it's being driven by, I think it's now 5 of the 6 largest banks in the world across the US and China are all using TigerGraph to enhance their fraud detection. And I use the term enhance carefully. We're not replacing the existing fraud detection systems. We are adding into those systems. And what we're doing is we're adding context, more context to the data. And what we mean by context is we are able to look at much more extensive relationships. If somebody's applying for a credit card, we can look 10, 12 hops out to see who they know, what kind of device. Is this a known device? Is this a known phone number? Is this a known address? Do they know the same people? And that way we're able to provide a lot more context before a decision is made to approve or deny a transaction. So what I'm showing here is 3 tables. And what we've done is we've taken an industry standard fraud data set. I think it's on Kaggle. It's not something that we made up. And what we're showing is with the window on the left, when we don't run any fraud detection, that there are 1,320 frauds that go undetected. And what we're showing in the center is what happens when we start to feed in traditional fraud supporting information on a relational database. Now, the relational database is limited to a certain extent to rows and columns, which in our terminology as a graph vendor means you can kind of do 1 hop or at the most 2. And after that, it's very difficult because you have to do joins and multiple joins, and this data is changing on a regular basis. So most customers kind of stop at a 1 or 2 hops. And what we see is there's a pretty good improvement, sort of 320, but still 326 frauds went undetected, and we denied 70 legitimate claims for a transaction. So what we did was we took that same data set and we put it into TigerGraph. And from here, we can add in a lot more context. I think we have about 30 hops and 30 days worth of information feeding into this system. And what we can see is a 48% improvement in the frauds, and we can see a 60% improvement in the false positives. These all sound like great numbers. So this is something that's been done on an industry standard data set. And if anybody wanted to see how this is done, we'd be happy to share the whole process and the algorithms that were behind this. But here's the sort of real live example. This is a very large bank in the US. So we have several of these, and it kind of shows how long it takes to implement the system, which is quite quick. So there's 20 terabyte of card data. The whole proof of concept was run over 6 weeks. And being honest, banks aren't the fastest moving organizations in the world. So about 4 weeks of that was waiting to get access to data and internal systems. And the challenge we were given was to show an uplift of around $10 million of fraud detection on their test data set, which we were able to do. And then they went into the full scale deployment, and it's a $16.5 million ROI just in terms of the uplift in fraud detection within the first 12 months. And what we're seeing is this has become something that's becoming a big wave now across finance institutions around the world. I think most people are beginning to understand that adding that additional context to the data using graph will allow far better accuracy in terms of fraud detection and also in terms of false positives. So we work with organizations like Whiteclay to drive, just to show this is sort of how we start the planning session, because it's not a lengthy process. So companies like Tygraph, we need to work with end-to-end solution partners like Whiteclay. And what we start with is a half-day session where we will, what we call a fraud challenge. And the idea, most of our customers in this space, they know what their fraud rates are, and they typically have people working on this full time. So we will come in, have a half-day planning session to see how much we can improve their fraud detection by and reduce their false positives on what they typically have as a test data set, probably using PageRank or Louvain algorithms. That's what most people are using in terms of their fraud detection. And in fact, recently with an online company, during this half-day session, we were actually able to load in their test data set. They were running at a fraud detection of around 4 to 5%. And within a 3-hour window, we were able to show them that we could detect an additional 25%. And, you know, when you're talking about fraud running in the tens of millions of dollars a year, then that's a pretty immediate payback, which is, I think, is a good thing for both us and our customers at this time. So look, that's, you know, what I wanted to do is just very briefly walk you through what Graph Analytics is all about, explain that it is part of the data governance story because we see fraud as data governance as well. It's a logical extension of that. So Amit and Asit, I think that ends my session. If there's any questions, we're happy to take them now or take them separately.
Thanks, Martin. We have a question. Yes, Faraz, I think you have a question out there.
Hi, Martin. Thanks, Amit. It's Faraz from Accenture. Thanks for the great presentations. I was curious to just understand, you know, if there are any specific examples or case studies around, you know, how Isaac and Tygraph sort of complement each other, or how you've sort of delivered benefits to your customers by working together.
So that's a nice question for us. So ideally for us, you know, as Martin explained, you know, for any kind of a fraud analytical use case, data standardization and data formation of a data repository and doing certain transformations before it gets landed into a graph database actually makes a lot of difference. And you can achieve a fraud analytical use case way more faster. And that is how we combine our strengths. So for Isaac, basically, Tygraph is a destination. Okay. So while we transform the data, put certain rules and logics into it, and then finally dump it into a Tygraph database. Martin, you would like to add something out there?
Yeah, look, I think what we've been talking about with Whiteclay is that having graph capability is a logical extension of Isaac, and that's what we've been working towards. It's a capability that customers are asking for, and it's something that we'll deliver together.
Sounds good. Thank you. I'd be keen to understand this a bit better, but we'll follow up offline. Thank you.
Thank you.
Thanks for us. Thanks, Martin. So idea was, you know, so fraud detection basically has been there for a long time now. But fraud detection has been based on supervised learning techniques, as Martin was speaking earlier, and which is not the idea. Okay, so it is not. If you have a fraud detection system which is based on supervised learning techniques, it will not be able to track the novel fraudsters, right? So there are fraudsters today out there wherein you cannot catch them with supervised learning techniques. Now, what makes a difference is unsupervised techniques. Now, when it comes to unsupervised techniques, it actually depends on a typical variant of anomaly detection, where the graph-based approach is very promising, and that is why Gartner has been, exaggerating a lot on these technologies. And TigerGraph, Courtesy is leader out there. So with that, what I will do is we can have a 5-minute break out here before we continue to the next session with my friend and colleague Gert out here. So if people want to take a break, we can take a short 5-minute break.
I love the idea of a virtual break. Let's do that. That's good.
You can catch up a coffee, or you want to go to the washroom, whatever it is.
Yeah, I'm going to start sharing already to see that it works properly when we start.
Yeah, how come you get that privilege, Gert? I have to come in cold. Unbelievable. It's favoritism. It's favoritism.
What shall I say, my friend?
Okay, so while some people are on break, I would like to introduce Gert out here. Gert, again, he's a seasoned management and sales professional with over 20 years plus experience inside the IT domain. He's been around inside the domain with giants like Microsoft, MarkLogic, Cloudera, Mapr. In fact, Martin and Gert were in Mapr, I suppose, together. And I suppose, Martin, you were there a little before Gert, right? Or you guys?
We overlapped. We worked together. No, it was good. It's nice. I'm looking forward to Gert's presentation. That's all I can say. I've got a lot of questions, but I'm looking forward to it.
Yeah, so did I to Martin's. Always a pleasure.
So Gert, meanwhile, you can, I'll stop this share screen. You can actually go ahead and share yours.
Yes, please. Still have to hand over the ball.
You have the handle, Gert.
Yep, got it. Okay. Can you see my screen in presentation mode, or?
Yep, we can.
Okay, good.
So we have 2 more minutes and you can start.
Sure, ready when you are.
Gert, you can start.
Okay. So thanks everyone for joining. Thanks Martin for the presentation before, and also all the colleagues from Whiteclear as well. My pleasure to be here. And I think it is a very, very interesting way to look at the 3 presentations that we have seen. So from my summary, I would say the starting presentation that we have seen with the technology and the product of White Clay, this is where you define the business rules. This is on a business level layer, so people that know about their domain within an organization, how they would be able to define data, being a creator, a consumer, and what have you. Then we have heard from Martin about how these people mostly humans would be able to take a look at data that is very complex and has a lot of connections and connectivity that usually as an individual human you could not digest. With technologies like Tiger Graphs or Graph Database, it is a visualization, so easy for us to digest and to understand. And what I'm going to do is to tell you something about the boring stuff underneath, which is the data, because we have all agreed that data is very important. But how does data come into play, and how does data play this role from a governance point of view? And what is architecture of the data, or the way that you store the data, the way that you handle data? How does it come into play when it comes to governance? So I don't want to talk too much about our company. Probably HPE is a known company. HPE has a vision with its new software portfolio called Ezmeral. Ezmeral is kind of a brand umbrella that we have put around all our software efforts, and that are mainly currently covering things like former MapR, so the company that Martin and I used to work for. It also includes a company called Blue Data that has been recently acquired by HPE, as well as Kubernetes support and a lot of other things that you will see coming to the market from HPE. And I'm referring here to the data fabric. This is the former MapR technology. So it's exactly the same bits and bytes. And the vision of HPE now with what we call data fabric, so also known as MapR previously, is to provide a modern high-scale data infrastructure for all sorts of files, so for all sorts of data and objects, in a cloud-grade, reliable way to span from edge to cloud with a single governance. So this is obviously a very bold statement, but it literally summarizes almost everything that our customers these days care about, which is the infrastructure to hold the data, to store the data, to process this data, to scale it up. If you are an automotive company, if you're looking for the autonomous driving projects, these are huge amounts of data that we're talking about. They want to go into the cloud, not only into the cloud, but have a hybrid strategy. And most of the time, the edge devices become more relevant. So an edge device can obviously be something like a mobile phone, but edge devices can differ. It could also be a car that could be considered as an edge device. It could be the cellular tower of a telephone company. That could be an edge device. It could be an MRT scanner if you are a company that builds healthcare components. So various components, various machines can become a edge device that needs to be taken into consideration from a data analytics point of view, as well as from a data governance point of view. So let me take one step to take a look at what the market and the customers are currently telling us. So we see two major trends. One is the major technology trends. So that's something like going into the cloud, acting mobile, going to IoT and the edge, and leveraging ML and AI. Like we just saw with Martin's presentation and with Amit's remarks on, you use machine learning for the prediction of the model for the fraud detection. On the other hand side, we have major investment trends that we see with our company, with our customers. So one, obviously, with the COVID-19 impact is the cost reduction one. So you want to reduce cost as much as possible. But on the other hand side, the other threes are the opposite of cutting costs or saving costs. It's investment. It's new data-driven applications. This is something that hasn't been there before. It is real-time analytics. We haven't been able to do real-time like we are now because of the increased capacity of storage and compute. And most of all, and the latest development is into containerization. So not segregating data and process and compute, but putting it together with all the runtime environments for an application to make it easy to deploy it from the smallest environment to the largest one. But what combines all of this is, as we agreed previously, data and the demand for the analytics. Whether it's for something like the fraud detection use case, whether it's for a customer 360 application, whether it's for a risk analytics application, whether it's for training a model. Analytical use cases are the driver to collect data, to store data, and to process data. So that is also where the HPE Ezmeral portfolio fits in. And now let's take a look at what we call the microservices origin and their challenges. So these different new technologies and applications mostly are built on microservices, and they come with special challenges. So let's take a step back and go back to the origins of the microservices, which is maybe 10, 15 years ago. There was this new technology called Hadoop. So everybody told you, like on the left-hand side, you take all the data that you have, regardless what it is, whether it is just very, very data that has almost zero SLAs and almost zero restrictions on it, like any kind of standard data, or whether it's something like credit card information that is very sensitive. You would throw all this great data on the left-hand side into what you call a data lake. You apply this nice elephant on top of it, which is the Hadoop technologies, and outcome, in theory at least, on the amount of data, the value would increase and you would just harvest the dollars that would be gathered from this approach. So this was like the perfect example. This was like the perfect marketing promise that you would get of this perfectly looking and most likely perfectly smelling and tasting burger. So let's move forward 10 years later, 15 years later, where we are right now, maybe the last 3 years. This is more or less what we have heard from our customer, what they have experienced in the past with this great technology. So it's something like a burger. It might even taste the way it should taste, but it's probably not what you expected. So you got oversold on it. Why is that? The reason is obviously because it's not a data lake, but it's a data swamp. So you throw data into this repository, and you try to apply this Hadoop elephant, that small one, on it, and out comes very little amount of value, very little amount of additional revenue. Why is this the case? If we take a deeper look into this, the case is, and this is one of the drivers that drives especially also the compliance, it is not that just one elephant. So you're not just taking the Hadoop workload and the Hadoop tools, but there are various other workloads and tools, like, for example, all the NoSQL databases that you see here. So Cassandra, MongoDB, for example. You have all these things like Kafka and RabbitMQ, which is the publisher subscriber services, that you would need to build something like a modern publisher subscriber systems. There are these legacy technologies that you want to involve and the data that it contains, like Teradata, like Exasol, like Exadata, like SAP HANA. There are these modern things like the Docker technologies, Kubernetes, and all the ETL process, so the extract, transform, and load that is required, which means that literally each and every of these tools, so like the Hadoop elephant or Cassandra or MongoDB or Kafka, is a workload for us as HPE and the data fabric. And each workload comes with its own requirements for infrastructure. So you have to have a dedicated cluster with certain infrastructure requirements. You have to have certain admin tools. You have to have their own monitoring tools. But what's most important from our point of view in this discussion is that most of these tools come with their own security. There is no such thing as a unified security. So you have to build dozens of different security systems protecting different workloads and protecting different tools and its data. So for our customers, these workloads become a lock-in because they are locked in by the requirements of the individual workload providers and tool providers. So that said, the complexity is even worse. And this is also when we take a look at the governance point of view. So creating these circuits, creating those individual clusters that would contain the relevant data for analytical purposes, whether it's a Hadoop cluster, whether it's a NoSQL cluster, whether it's a middleware cluster like a Kafka cluster or anything else, creating those circles is very hard. Maintaining them is very hard. But the lines in between, which is that the same data that you might originally store in a NoSQL database also needs to be analyzed partly in a Hadoop cluster. What you do is You copy the data, you ETL the data to make it usable in the Hadoop cluster. And now you say, okay, by the way, I want to have the results of what I have now been copying from the NoSQL cluster into the Hadoop cluster, processing it there, and taking those results and putting it into a data warehouse, and bringing parts of the data warehouse data back to a NoSQL database, and from there back into the Hadoop system. That comes with the obvious challenges of the footprint of the data, with the ETL process of the data, but from a governance perspective, it comes with an even bigger challenge. The challenge, how can you make sure that the security system that was natively applied, initially applied, for example, to the NoSQL technology, is kept the same when the data is copied to the Hadoop cluster. And from there on, the results are copied into the data warehouse. And from there on, another result set is pushed back into the NoSQL cluster. How can you make sure that the data, when it comes with an SLA, so credit card data comes with an SLA, the SLA is not on top of the infrastructure, it's on top of the data. You have to make sure that this mission critical, or in this case, private data, is protected, regardless whether it's stored or processed in a NoSQL database, in a Hadoop cluster, or in a data warehouse. So that is the biggest challenge that we see with our customers when it comes to what is the art of possible, what can I build theoretically, and what I'm allowed to build, and how can I make sure that if something goes wrong, if I have an audit, I can make sure that I can follow up exactly who touched the data, when the data was touched, by whom it was touched, by whom it was manipulated. You have to make sure that this is all under your control. And here comes the HPE Ezmeral Data Fabric. We have a different architectural approach that is leveraged by various of these large customers. And for example, American Express is doing a lot of the fraud detection based on the data fabric, which means that they are leveraging graph technologies and graph databases on top of our technology, on the data fabric, that holds the data and processes and analyzes the data. So does, for example, Societe Generale and other large banks, as well as all sorts of the Fortune 500 companies. So let me give you a very short overview on the architecture and why this is really important. It's technical, but I want to make sure that you understand this. So the data fabric can be deployed everywhere. Very important thing. You can deploy this on-premise in your own data center. So for the data that currently resides already within your own data centers, which is by IDC studies, roughly 70% of the data currently. But it also can be deployed in any kind of cloud. So whether it's the Amazon cloud, the Azure cloud, the Google cloud, whether it's Alibaba in China, or it's any kind of private cloud. And it can be deployed on edge. So the same technology can be used everywhere. And in essence, what the data fabric is what we used to call, when it was the MapR days, it was called the MapRFS, which is the MapR file system. And this, as boring as it is just a file system, an NFS and POSIX compliant for the technological freaks here on the webinar. It is POSIX and NFS compliant. This file system is the key differentiator from an architectural point of view that enables an governance down to the physical file system layer. And this is really important, because what we have understood and learned from Whiteclay and from TigerGraph is that their definitions, their way of approaching governance is on the human side, is on the business side. So the business and the humans, you usually don't know anything about how the data itself, in the end, is physically stored on a file system of a server. And that is important from a governance point of view, even though that it might not be looking important for anyone that we are usually talking to. So this file system, in essence, is the foundation. We have APIs, again, just for the technical folks here on the call, that enable to get data into the platform and get data out of the platform. These are industry standard APIs and or open source Apache APIs. So this is the API layer. And on top of that, we have what we call the applications that are leveraging the data that they need. So let's take a step further and see what the results of leveraging such a unified technology like the data fabric compared to the circles and lines diagrams leads to. It leads to certain savings when it comes to the CapEx and OpEx of such data platforms. Because as you can imagine, if you don't need dedicated hardware, dedicated infrastructure, dedicated environments for individual workloads, but can run multiple workloads on the same hardware because the data is not copied, it's stored one time, no copying, or we're trying to avoid as much copying as necessary, you can significantly reduce the CapEx. So can you do with the OpEx? Because if you don't need to have these environments, you don't have skills in place for the different technologies. And it also lowers the OpEx because it lowers the amount of work that you need to put into when it comes to governance of the data. Because the data ideally would reside in a single repository, which could be the data fabric. So let's go into the technical features that hopefully will elude how we enable the specialities and the USP when it comes to governance with the data fabric. So one thing is what we call the global namespace, which means that you, when you are responsible for data governance, you still want to make sure, like Martin explained, you want to make sure that customers still can do transactions. If they wouldn't do any transactions, you would have zero fraud. But obviously you have to do transactions and as many transactions as possible because that's driving my user experience. So the same thing is true for sharing data and exchanging data and copying data. So it might be necessary, like in that case, that you have to have, for governance purposes, separated instances, one in the US, one in EMEA, one in Asia. I mean, this is obvious because of safe harbor regulations and all these kind of things. Still, if you were to be the CISO, so the chief security and intrusion manager for a company, or if you are the head of the data governance, you still wanted to have access to all the data. That is not guaranteed on a regular basis, but it's guaranteed if you needed to do so because there would be a case of fraud. There would be a case of data breach, for example. Then this technology feature that we have, the global namespace, that is usually used for something different, and I don't have to go into the details here, but this tool is used to give you, as the head of governance, access to the data and to see where the data resides, how the data is combined, leveraging technologies, for example, like ISAC and like TigerGraph. So that would be one of the features that is built into the platform. Another feature, or other features that we have, are partly infrastructure orientated, like we have a design that in which failures are common. So we accept that there are failures in the system. Systems will fail. The larger the systems, the more complex the systems, the more distributed the systems will fail. So our technology is ready for failure. We have built it in a way that it's failure tolerant to its limits. It is self-healing. There are things built into the platform that help to heal a cluster. If one node, so if one element of the cluster fails, there will be the other elements taking over the workload. And it is automatically done and transparently. So is auto-balancing, which means that the workload can be balanced across the nodes that are in there. But then there are other things that I like to go to, like snapshots, mirrors. These are things that also have a high relevance when it comes to data governance. Again, just for the technical people here on the call, I share this slide, but what I want to tell you about it is snapshots is a technology in which you can do a logical copy of the state of data. So you can do a logical copy, not a physical copy. A logical copy is more like a pointer of the data. And this technology is used for decades, I would say now, to be able to restore in a disaster recovery case. So you could be able to rebuild a data warehouse if you have snapshots of your data, which is, you usually do maybe snapshots on an hourly basis. After 24 hours, you consolidate into a snapshot of 24 hours. After the 24 hours and a full week, you consolidate into one snapshot that has the full week. And whenever there is any kind of disaster, Whenever there is anything that needs to happen, you can just roll back to where you have been and to a state that you feel comfortable with. That is very important to also track and trace in case of a governance issue that you have, in case of a leakage. You want to see up until which point the data has been correct. Because once you have detected there has been a fraud, once you would not be able to prevent the fraud, but you have been now becoming a victim of the fraud, you will need to make sure that you obviously stop the fraud from happening. That's one task. But there's another task that is even more important, is how can I make sure that I go back to the point in time before the fraud happens? Because that is the status that I need to get to, because all transactions that have been taken place since I have detected the fraud are most likely not yet approved. So you have to rerun them and to see whether they can be approved or not. So having snapshots in place is a very important feature down to the physical file system layer that we can enable with Data Fabric, and that can help you to achieve these two things, which is on the one hand side, to go back to the point of where everything was fine when a fraudulent or a kind of a disaster happened. And secondly, to make sure that you get each and every transaction, each and everything that happens to the data or to the system, to make sure you find out who did it and when was it done. The next thing that we have is something that we call mirroring. It's something comparable to the snapshots, which means that you can mirror data from one environment to another, or from one location to another. That is also very important, because sometimes, for example, when you go back to the global namespace example that I gave you, you have these 3 clusters, for example, in 3 different continents. Okay, that is necessary because you have to segregate the data physically in a safe harbor environment. But there might be the case that there are 3 different developer teams, each developer team sitting in each continent. They surely want to work together. They surely want to share their findings about, let's say, fraud again, or their findings about the working and the precision of a particular machine learning model and algorithm. So how can you make sure that this data can be shared, still leveraging the restrictions of a safe harbor environment, and make sure that this data is shared in a way that the data can be processed locally, because it might be a significant amount of data. So you don't want to execute an analysis or a query in Europe remotely from Asia and get the data over the line to Asia, because the connection is fairly limited usually between these installations. So you want to make sure that you have data gravity, which means that the data mainly is processed and stored where it resides, but it can be duplicated, it can be mirrored from one environment to another if required. Another capability that is built into the platform that enables development and that also guarantees the governance of the data. Finally, or thirdly, I would say, when you talk about large amounts of data, really large amounts of data, petabytes of data, you have to have the requirements that you make sure that the data is stored according to the value. And that brings us back to the initial presentation from Whiteclay, where we were talking about the value of data over time. So data that ages becomes less valuable over time. That means that analyzing this data brings less value in general. There are exceptions, but this is the general case. So if we assume this is the general case, then that would mean that if data ages, we can't store it in the same environment that we use to store the hot data. So you see those 3 buckets here: the frequently accessed data, which is more or less, in short, hot data; infrequently is warm data; and rarely used data is cold data. So we have something that is called built-in software-defined storage theory. You can define different buckets of data, like here on the right-hand side in green, the performance optimized, which is the hot data. You have on the left-hand side the capacity optimized environment, which is the warm data. And on the right-hand side again, down on the slide, you have the cost optimized one, which is maybe an S3 base. So a kind of an object storing environment. You can define topologies, which is the infrastructure. So this could be the performance optimized layer, could be a purely SSD-based storage layer. The capacity-based or optimized layer could be a purely HDD-based layer, which means that this one, the performance optimized, is obviously way more costly than the capacity one. And S3 would be kind of an object store that you could either buy from the cloud or leverage a technology that leverages S3, which is even less costly than HDD environments. And based on rule-based subscriptions that you can do and define by yourselves, you can let the data tier and age over time from one bucket to another, transparently for your users and transparently for your applications. But again, it's very important for all of these buckets or for hundreds of more that you can build, the security won't change. The security will be defined on the platform level, regardless what topology you have underneath. Thereby, you can guarantee that the security that you have defined once for the HUD data remains the same for the capacity optimized data or for the cost optimized data. And even if it gets warmed up back into any of these layers, the security is totally untouched. Very important. Finally, the cloud. We talked about the cloud. So all of this, like I explained, can happen either in your own premises, so you can have all your data in your own premises, or you can have parts of your data residing or being moved into any kind of the clouds, and you can have it on the edge. And here again, it is important that if the data would move from any environment, whether it's on-premise to cloud, or from cloud to cloud, or from cloud to edge, or from on-premise to edge, again, the data security would remain unchanged. Nothing changes the SLAs on the data. So with one platform that handles all the metadata of the data itself and the data itself down to the physical file system layer, you make sure that the data is secured in the same way like it was secured initially, even if it needs to be transferred and moved from one environment to another. That said, there are other capabilities in here, and I don't want to go into the details of the technical like encryption mechanisms that we have in the data fabric because they are not really relevant, but you should be aware this is something that is existing. So we can connect to LDAP environments. We could connect to Active Directories. We could use Kerberos for the security people in here. But the most important thing is here on the left-hand side down low, which is the number 3. It's the robust auditing. If you want to do auditing based on the definitions that you might define in ISAC, the technology that White Clay has presented to you, that you have surfaced, that you have visualized, leveraging the technologies like TigerGraph, the problem is once you would get to an issue, once you would get to a fraudulent transaction, once you would get to a data leakage, you needed to get the log files. You needed to get the physical log files of the server to understand who, which person, which application, which technical user has changed the data, has changed the security, has changed the authentication or authorization or whatever has been changed to enable the fraud, to enable the data leakage. And here is where we have a unique selling position, which is given the fact that we are owning the file system. As I presented to you, the MapR file system is something that we own. The data fabric file system is a patented file system that we own. We give it to you when you buy into our technology. And this enables us, because we need these log files for optimizing the file system anyway, to make it as performant as possible. But this also enables you to get access to exactly those log files. Not everyone, obviously, only in a 4i system, only the people that are allowed to do it. So the head of governance, for example, these people would get access to the data and could leverage the data in a stream to make sure that they can understand who worked on the data and who did something to the data. So summarizing these things up, we have a single environment we have single authentication and single authorization on all the tools that you would leverage on all sorts of data, whether it's the tools that we provide or whether it's tools that you leverage from the outside, leveraging those APIs in the middle, and a single governance on top of it that enables you to apply this governance, to define those rules, leveraging those technologies like the ones that White Clay is presenting to you, and to visualize it in a way like TigerGraph would do it. And we would enable that everything that is defined in these tools is applied to all sorts of data in each and every deployment down to the physical file system layer. That is what I wanted to present it to you in the given time.
Thanks, Kurt. I think the whole HPE container platform forms a very strong foundation when it comes to microservices, and that is how it complements Isaac and TigerGraph, because that is the first layer of foundation which is like deployed inside an environment. And with the whole plethora of microservices based architectures getting traction inside the market, HPE has a very good portfolio out there. So we are open to take certain questions. If people have, you can pop in raising your hands. Okay, I don't think there are any questions. Thank you, everybody. Thanks, Gert. Thanks, Martin. Thanks, Adi. Thanks for all the contributions out here, and very good sessions. Thanks, audience, for joining in. I hope it was decently insightful sessions from each and every one of the presenters. And we will soon come out with next line of webinars, wherein probably you will have some more interesting OEMs to align with or use cases.
Thank you very much, everyone. Have a nice one. Bye-bye.
Thank you. Bye-bye.
Thank you. Bye.
Thank you. Bye.
Thanks, bye.